Video 18-2, non-reversible reactions and common ion effect. So, non-reversible reactions. How come some reactions will not run backwards? Okay, in general, reactions that will involve ions that go to completion, in other words, only the foreign reaction works, will be one of these three types of reactions. Okay, it's either a reaction where one of the products is a gas, or where you form a precipitate, or where the reaction produces products that are only going to be slightly ionized. In other words, the substance is either weak or a non-electrolyte. Okay, now the common ion effect. Okay, if you have a system that produces ions and it reaches equilibrium, okay, so a substance could be ionic, could be molecular, but it produces X plus and Y minus. Okay, what happens if you add an ionic compound, a salt, like NaY to it? Okay, well, this substance, because it has sodium in it, sodium's always soluble, it's going to break up into Na plus and Y minus. Okay, now, this Na plus does nothing to the equilibrium. Okay, you add Na plus to this equilibrium, nothing happens. But because we are adding Y minus, okay, this substance right here, all of a sudden the system says, whoa, too much of this stuff, and it's going to end up shifting to the left. Okay, which means the amount of Y minus that you have will decrease slightly, X plus will decrease slightly, but okay, if you add an ion, it reduces the amount of ionization that can take place, and it could cause precipitation if the solution was saturated. Okay. In other words, we get more of this stuff that is put together and less of the X plus. Okay, when you shift it to the left. So let's take a look at an example. Okay, we're going to start out with acetic acid, dump it in the water, it reaches an equilibrium with hydronium ion and the acetate ion. Okay, what would happen to the pH if you were to add sodium acetate to this? Okay, well, what's sodium acetate? Sodium acetate is NaC2H3O2. Okay, when you dump this in the water, it's going to break up into Na plus and C2H3O2 minus. Okay, so the sodium is not present here or here. Okay, but the acetate ion is going to affect it, so it's going to shift it and drive it to the left. Okay, now, answer the question, what happens to the pH? Well, when you drive it to the left, this concentration, the H3O concentration, will decrease. Okay, so remember what happens to the pH when H plus or H3O plus concentration goes down. Okay, since we're getting less of this, it's becoming less acidic, so the pH will increase. Okay, now comes a little bit harder problem. So this is where all the math stuff gets involved. Okay, for our system, we're going to use AB, and it's in equilibrium with its ions, A plus and B minus. The KEQ for this is 4.0. Okay. Initially, you have 1.50 liters of this solution. Concentration of AB is 2.50 molar, and A plus and B minus are 0. So in other words, the system hasn't reached equilibrium yet. Okay, so all we have is AB. There's no A plus or B minus. Okay. What will the new equilibrium concentrations of the substance be after you add 0.50 moles of AB? Okay, and assume that there's no volume change also. So, first thing you have to do, okay, make sure whenever you're doing this type of problem, all your calculations are done in moles. Okay, so initially, moles, don't forget, moles are equal to molarity times liters. So you had 0.250 molar solution of AB times the 1.50 liters, so you have 0.375 moles. Okay, now set up a table, okay, a little chart, and make sure it's in moles. So initially, 0.375 moles of AB. Okay, then what happened? And initially no A, no B. Okay, now what's our change going to be? We're going to add 0.50 moles of the AB. Okay, so what happens? Is the new concentration going to be 0.5 plus a 0.375? Okay, it would be if nothing happened, but because we add stuff on this side, the system is going to shift to the right. So it will decrease. We're going to lose some stuff. Okay, what's going to happen to the amount of A plus? Obviously, this has to increase. What's going to happen to the amount of B minus? This will also increase too. Okay, now how much will it increase by? Well, we don't know, so we'll call it X. Okay, but every time you get 1 mole of A plus, you have to get 1 mole of B minus. So B minus will also increase by X, and since this is a 1-to-1 ratio, whatever you increase by, this has to decrease by the same amount, so by X. Okay, now what are the new concentrations going to be? It's whatever was there, 0.375 molar, plus the 0.500 molar. Okay, so this is going to be added up 0.875 minus X moles. This is whatever was there plus the initial, or the initial plus the change. So that's just going to be X. X plus 0, that's also going to be X. Okay, so these are the new concentrations. Okay, next step, take those concentrations, solve for X, and then plug it back into the new equilibrium equations and solve, and then make sure you change everything back into molarity. Okay, don't forget we're solving for moles, so in other words, divide by the volume of 1.50. Okay, so in other words, what do? The KEQ was equal to the concentration of the products, A plus times B minus, over the reactants, AB. Okay. We go back and look. What does it say? AB is 0.875 minus X. A is X. Concentration of B is X. Okay. So, what does that mean? KEQ, which was equal to 4.00, is equal to, that's X, that's X. So we're going to have X times X, or X squared. On the bottom, AB was equal to, go back and look, 0.875 minus X. Okay, 0.875 minus X. Okay, so now solve for X from this equation. Okay, cross multiply, and you will come out with, let's see, 4.00 times 0.875 minus X must be equal to X squared. Okay, multiply that out, and 4 times 0.875 will give you 3.50 minus 4x is equal to x squared. Okay, so we can move everything over. Let's move it over to the other side. So we end up with x squared plus 4x minus 3.50 is equal to 0. Okay, now how do you solve for x? Well, use the quadratic formula. Okay, x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay, and what is what? Well, a is your coefficient for x squared, which is 1. B is your coefficient for the x, which is 4. And c is going to be your coefficient, or just your c, which is negative 3.50. Okay, plug it in, and you'll end up with 2 roots. Now, which one do you pick? Okay, don't forget. Go back and look at what x had to be. X has to be a positive number. Why? Because it cannot be a negative value. X cannot be decreasing from 0. And because we're saying we're decreasing, x cannot decrease and end up adding to our number. Okay, so make sure you pick the positive value. Okay, so plug your numbers in, solve for x. Okay, and then don't forget, once you're done, x is not your concentration of AB, right? Concentration of AB was equal to the initial whoops, 0.875 minus x. Okay? Concentration of A was equal to x, of the A plus rather, and concentration of the B minus was also equal to x. Okay? And don't forget, these values were in moles. Okay? So once you solve for x, plug it back into that equation, that'll give you moles, and don't forget divide by the volume, okay, of 1.50 liters. So review, solve the problem and come back and tell me what's the new equilibrium concentration for AB. Which one of these is the correct answer?